is our lecture 25, and I will be continuing the topic on regarding to dam. So our today's topic will be comprising the factors affecting selection of dam. Okay, so let me show you the screen. Okay, fine. So now, as of now, we have collected enough study of dam, about dam. So today we will study about the factors on which the engineers will look after before selecting a site of dam, or what kind of selection could be the dam, or what scenario or the what site preference should be measured before constructing a dam. Okay, so let us first discuss about dam site selection. Well, first of all, before selecting a site for constructing a dam, we should know what is the ideal dam criteria. Okay, so let us come to the first point. A watertight seal placed in a river in order to create a lake or reservoir by impounding the stream flow. Mean that to make a ideal dam, it should have a watertight seal placed. Mean in a technical term, you can say that strata should be impermeable. Okay, so a watertight seal placed in a river in order to create a lake, so that dam or that storage will obviously create a lake or a reservoir by impounding, mean by collecting the stream flow coming at the face of upstream side. Okay. So that should be the first criteria. What should be the second criteria? It must be stable under all loading condition. So whatever be the condition, it can be snow load, it can be earthquake, wind load, or water wave load, or any impact load, whatever be the load, it should resist all those load. Or I mean that structure should be stable against all those loads. Okay, so that should be the preferable criteria. Next, it must resist the hydrostatic pressure on its upstream face. So that dam structure is totally dealing with the water pressure. So the hydrostatic pressure is the most important load that we have to consider while designing a dam. So that hydrostatic pressure at the upstream side face has to be considered very considering it. And next is the destructive influences of water percolation and possible uplift due to it. Mean, say what I have already taught you in the previous classes in Blitzkrieg theory. Say if water tend to percolate from the foundation, so what happens that there will be an occurrence of uplift pressure, right? So that uplift pressure can topple off the dam or a reservoir or a structure. So we have to so it may create a devastating situation, right? So we have to look after that factor as well. Okay, so now investigation for dams. So the factors to be considered are, first point is the geological condition. So let us read that. The effect, the location, and that geological condition. Under this point it comes that affect the location and construction of foundation, abutments, dam itself and spillways. Mean that geological condition may affect that location or the site of the construction, the foundation, the abutments where that main dam will distribute its force, and the dam itself and the spillways. The next point comes is long and short term stream flow. So we have to consider the long term stream flow and the short term stream flow. Next point, it comes the rainflow and storage reservoir characteristics of the proposed dam catchment. I mean, you have to get the data or the reading of the rainfall on that particular site where you are going to construct that dam. So what is the rainfall? Just a minute. So what is the concerned rainfall data on that particular place? Next is the accessible road. Mean the accessible communication is very important thing. Next point is local availability of earth and rock materials and their suitability for dam construction. So locally, if we are having the materials to construct the dam locally and in a very near places, so it would be quite cheaper to make that project happen. So it will be quite preferable. Okay, so under this point it comes that availability of earth. Under this point comes is the concrete aggregates. Next is so concrete aggregates, whatever be the material, maybe it's earth or rock, whatever be the construction to be whatever the requirement is there. Okay, the next point comes is the degree of permeability of rock formation on which the dam is to be placed. Okay, so in order to make a huge amount or a huge mass of structure, you need to have a very solid foundation, right? So to get or to reach the rock foundation, in the bottom of the foundation, bottom of the foundation surface, it is very much essential. Okay, so the degree of permeability of the rock formation, this data or this information is very much important before constructing a dam. Okay, so under that comes is that degree of permeability of rock formation, it may affect hydrostatic uplift pressure and the degree of grouting necessary to control it. As I have already told you that the degree of permeability, if it is the percolation under that foundation happens very quickly, then the uplift pressure may rise also very quickly. So what happens, we need to it may automatically affect in future on the hydrostatic uplift pressure and the degree of grouting mean, just a minute. The degree of grouting mean actually this terminology implies injecting. Okay, so if somewhere or in some place if there is any deficiency or some place if any crack occurs, so what happens, we tend to seal it up by grouting. Okay, so it is a mechanism of filling up some cracks or deformation. Okay, so by grouting that can be controlled. Okay, so the next point is planning for river diversion to occur while the dam is being constructed. Under this comes cutting a temporary channel which bypasses the dam itself and installation of large pipes under the dam. Okay, so say this is the flow of river coming over here. Okay, and you are deciding to make a dam here. So what happens, in order to make a construction, you need to create a obstruction here to make that dam. So you cannot hold that water for a very long term, right? Hold that water stream for a very long time. So you have to divert that channel, or you have to divert that flow to other direction, just in order to make that construction happen for a while. So that planning for river diversion is, planning that diversion thing is very important factor to be measured. Okay, so the next point comes is provision of sites for like water intake structures and pumping station for water supply dam. Mean, in order to channelize or divert that water, you need to dig a very large amount of space, and also channelize some water through a pumping station to another place. Okay. So next point comes, under that also it comes penstocks. Well, penstocks are are often used at mill sites to control the flow of water. Penstocks is actually used to control the flow of water through the mill wheel. Okay, these we have to see the provision whether we can construct this as well or not. And next is the power station in the case of hydroelectric facilities. So we also have to concentrate on this thing before constructing a dam, whether we can enable these things with that or not. Okay, the next point is the very important point. We often miss this or avoid this part, but as a future impact or environmental crisis, we need to check out this point, which is an environmental impact study. So under that it comes that a short and long term effects of the proposed reservoir and the construction operation on the region. So we need to see whether before constructing the dam, all the planning, all the accumulation of materials, whatever, and after constructing the dam, what are the impacts that project has made in that particular place? I mean, what impact on environment that it made any impact, any worst impact or not, in a short term and as in a long term effect. We have to measure that, or we have to look after that actually. Next is aesthetics, plant and animal ecology, fish preservation and public amenity of reservoir and downstream reaches. So these are the very essential point we also have to look after while constructing these structures. Well, next is noise and dust hazard in construction. Well, this is a very eminent part of any construction. And next is the effect of the dam on the regional microclimate. Microclimate means on that particular site, that there should be, if you are, say, if you are, or to make a dam project, you have taken a dam project which will be completed by within 2 years. So within 2 years, there will be a huge or a massive construction will take place, right? So there will be some microclimate or regional change due to that construction, due to that heavy construction. So that effect has to be considered also in the study or in the planning of constructing that structure. Okay, next. The types of dam, we have already discussed about it. So dams are classified by the materials of which they are constructed which are, it can be used with art, another is art and rock, another we can use only rock, and another is concrete. Okay, so the type of dams, as we have already come so far with that, so I will just only read it out. So under embankment, the art, rock, and rock, this kind of categories can be segregated under this embankment section, and under the material considered for concrete structure, under this comes is solid gravity, arch gravity, pre-stress concrete, concrete arch, hollow gravity. So these are some categories under this material considerations. Okay, next, what geological factors to be checked before constructing a large dam? Okay, so this is also very important aspect you need to know. So the stability and safety of the dam on its foundation. This is very important point. Next is the water tightness, mean the permeability of the reservoir basin, mean where the storage of water will occur in the strata, over the strata or over the surface. So that is called the reservoir basin. So what is the permeability of that particular catchment area or the section? So that factor is very important to be checked. Okay, next point is the slope stability of the reservoir perimeter. So the reservoir perimeter slope stability, it has to be checked. I will come in the next slide about that, explaining that slope stability. Okay, and the next point is the availability of suitable local material for its construction. So these are some geological factors which have to be considered. Okay. So these are some points. Preliminary geological investigation of dam construction. So only civil engineers will not be associated with the whole project of constructing a dam. It might, if you have any idea about the project, I mean the project cost, maybe it may take 200 or 300 crore. Okay, so it is a huge project. So there will be an involvement of several disciplinaries. Okay, so these are some disciplinaries and studies which have to be accomplished. Before that, the civil engineering and the structural part, everything will come. So first of all, the study which is given here is a topographical study. So you have already studied this thing about, a little portion about in your survey study. Next is reservoir location, where you going, which place you are going to store the total water. Next is petrology study. Well, petrology study is nothing but the study about the rocks. It is the study about the rocks. So just checking the foundation, only the soil engineer is not required. There will be a necessity of geologist, a petrologist, a mineralogist, several disciplinary persons will be involved in a project, in these kind of huge projects. Next is mineralogy studies. Next, structural geological studies. Next, geological factors like foundation conditions, water tightness of reservoir, availability of construction material. Next point is general examination of rocks. Next is indirect study methods for subsurface investigations. Next, preliminary drill hole study. So the mechanical parts comes here, mechanical engineering parts comes here. These were all the geological parts. There is some construction material, the checking, the quality maintenance, everything will come under the construction management part. Okay. Next is the study of geological topo sheet. Next, study of I hope you have done this in your geological class, your lab. I mean, next is study of the area with reference to geology. I mean, in the area, in the particular area where that dam construction will be occurred, you have to check the reference from the geology study. Next is study of rock types, study of structural geology of area, history of the area with reference to rainfall data. So you have to analyze the total rainfall data throughout the 50 years or 80 years, whatever be the maximum data for that particular concerned place. Next is study of stream channel with differential order. Stream channels mean the river stream channels. What is the differential order mean? You have to be aware of the differential stream flow by which you can evaluate the differential load which will come onto the dam. Okay. The next point is study of seismic data of the area. Next is geomorphological study. Well, geomorphological study is nothing but the formation of the rock. I mean, it is the study about the surface of, I mean, above the surface study. Okay. So how the rocks are formation, what are the chemical changes happening, what are the physical changes happening. So that study will also be considered. Next is preparation of geological map of the area in detail. So it has been mentioned 2 or 3 times in this point. Next, study of core drill data and its interpretation. And next is detailed engineering geological properties of area. Well, these are the geological investigation for dam site selection. These points to be noted. Okay, now we will come to the topic of selection of sites. So this is also similar to the previous one in a much elaborated way. It has been given. So the selection of sites based on the following basis. So the first point is the topographical part. So here it has said that most suitable place must be chosen for construction. Ideally, it must be narrow gorge or a small valley with enough catchment area available behind so that calculated amount of water can be easily stored in the reservoir created upstream. Well, so our purpose of making a dam is mostly to store the water, right? So just think about if you like to collect or store the water, which one you will prefer? Will you prefer a bucket or a plate? Definitely you will prefer a bucket, right, to store a water. So it is most preferable to just so this part which I am showing. So this is maybe it is not an ideal type of part I am not showing. So this is a narrow gorge or a small valley. So in this place, enough amount of water can be stored rather than this. Right. So constructing a dam in front of this part is not mostly preferable, but constructing a dam in this part is essentially preferable by the engineers. Just to enable the storage, the maximum storage of the water. Okay, so next point is the location of spillway. Well, all dams should have an adequate spillway for passing flood flows. If a river gorge is narrow, then there may not be sufficient spillway width available and a suitable location on the periphery of the reservoir has to be found to locate a spillway. Well, now after selecting this type of preferable section, now just think, due to this narrow spacing, you cannot have enough width of spillway in this part of the dam, right? So you have to also make sure that you will be getting enough amount of spillway that that spillway can actually overpass, I mean that spillway can actually pass the overflowed water in the time or in the season of monsoon or a heavy water storage time. Okay, so you also have to check for the spillway construction as well. Just only selecting a narrow gorges of a site is not enough. Okay, next point comes is sedimentation possibilities. Well, the average quantity of sediment carried by the river has to be known as precisely as possible, which would give an idea of the rate at which a proposed reservoir way get filled up. Well, you need to also think about the sedimentation, that what amount of sedimentation that river may carry, and what amount of silt deposition it may cause. So what will happen, that extra sedimentation of silt will give an extra force to the dam, so you have to also check on that sedimentation possibilities. Okay, so next comes is the technical part. So the site must be sound as possible, strong, impermeable and stable. Strong rocks make the job of designer easy. Impermeable sites ensure better storage inventories. Site must be stable with respect to the seismic shocks, slope failures around the dam. So this is a very basic thing. You have all come so far before constructing or before designing or before understanding any structure. These are the things it is very much preferable to achieve for a designer, right? Okay, next part comes is constructional. Well, the site should be closer from the materials which will be used for the construction. Their non-availability will make the cost of project high. Okay. So the next point comes is the possibility of river diversion during construction. So I have already discussed about this part. So you have to divert, in order to divert a river, total river channel, it is a very huge task or a very huge constructional part which have to be achieved. So this part have to be calculated or have to be planned very minutely. Okay, next point is human welfare. Well, site selection should be done in such a way that it must cause minimum damage to public in form of destruction or failure. So ultimately, whatever we are doing, it should be into the welfare of the human beings. So by damaging them, we cannot just achieve a full success. Okay, so it has to be checked before that, before construction, this part. Next is economical. Well, the creation of the dam must not create ecological disorder. Fish culture is the first sector that suffers the major shock due to dam construction. It indirectly affects the other population. This will be actually ecological, not economical. Okay, that the dam should become an acceptable element of ecological setup of the area. So what happens, that fish, the flow of natural fish, basically fishes inhabits in particular seasons for breeding, right? So if we are just creating a block in the path of their natural flow. So it will definitely affect their their ecological system. So this fishing sectors are very much affected by these hydraulic structures. So we have to also just check that this can be minimized, at least this part. Okay. So the geology of site. So first of all, so this is a very important part. Let me, I'm just coming directly to the figures. See, let me just read it out first. Surface and subsurface studies must be carried out. These studies reveal the type, the composition and texture of the rocks along the valley floor. Well, you have already studied about dip and strike in your geology study. Well, the resultant force, here just see, let me come to the picture directly. Just look at the picture A. So this is the dam, this is the water, and that water is giving a load, or the water is creating a load in downward way, and the pressure will come in the horizontal way, right? So, and now due to this, the dam is resisting the forces or developing the forces is its own weight W. This is the T, I mean, according to this load, and this is the resultant force. So what happened if that foundation, see that foundation alignment is horizontal, so it will be much expected to be stable, because that forces are getting a resistance against that foundation alignment, because that foundations are just aligned in a horizontal way, right? Now this is also called horizontal bedded rocks. Now if that's top of the foundation, that scenario remains same, but the foundation alignment are changed. Just look at this. This is a dipping rocks aligned in this way. So just see that resultant force is not resisted by this. This is in a same direction, right? See, this R and this strikes are in the same direction. So this resultant force are not are being not be able to resisted by this foundation alignment. So it may tend to fail in this direction. So this kind of foundation is unsafe. Okay, now come to the next part. See, here that strikes are in opposite direction to R. So in that case, it is only safe against R, because it is only opposite direction. When it will try to project a force in this direction, it will try to resist in this direction, opposite direction, right? So this is only safe against R, but may not be safe against the other forces. So this is the most preferable bedrock, which is quite expected to be constructed on. Okay. Now, next, the selection of dam type, the material availability. I have already discussed about this. The seismicity mean the seismic reading, the earthquake reading, the seismic zone where that construction has been made. It have to be calculated. Next is the geology and foundation strength. So, what? Let me just read it out. This is, I can say this is kind of a fact. You can remember this. So, the existence of joint patterns in abutments, their orientation, inclination, and infilling may indicate the possibility of instability under loading from an arch dam and reservoir water. Such a site would be more satisfactory for embankment dam or an adequately dimensioned gravity dam. So, where the existence of joint patterns in the abutments, this kind of orientation in the places of this kind of orientation, the arch dams are not preferable. In that places, embankment dam and the gravity dam is mostly expected to be constructed. Next, where the possibility exists of differential deformation, mean the deformation in the foundation is not uniform. It is differential, mean in some place the deformation may be x, or in other place the deformation may be x1. So it is differential deformation. In those foundation categories, a gravity dam or an arch dam would not be suitable because it is a kind of a rigid structure. So if you construct a rigid structure over a differential deformation foundation, it will not be able to resist. So in that case, you need to make a flexible structure that it can resist that differential deformation. So in those places, embankment dam may be proposed, which is more flexible. Okay. Next is the hydrology. If during the construction season there are possibilities of partially constructed dam being overtopped by the flood of river water, then a concrete dam section would be preferred than an embankment dam section. So this is another important point to be checked. So if an embankment dam section is still proposed to be built, then adequate diversion work have to be provided for diverting the river flood water. So I have already discussed these topics. So just look at this. I am just showing you this picture. See, these are some different phenomenon what you can get in the time of selecting a site. See, this is in this place. It is not a narrow section. It has a overburden place. See, this is a maximum overburden. This kind of cross section you are just watching having a maximum overburden. In that case, what happens in case of wide valley, which I have shown you in figure, it is a wide valley with deep deposit of fine grained soil. Overburden favors earth. It favors earth fill embankment. So in this kind of section, earth fill embankment dam is mostly preferable. Now just look at the next part. The overburden is not that much higher to that broaded valley, but it has some of amount that overburden part. So that represents a river valley that has much less overburden would be suitable for embankment, gravity or buttress dam. So this kind of alignment may be proposed to construct for a buttress or a gravity dam with embankment. Okay. Next is, this is a narrow valley. So in this kind of, for this kind of orientation, the arch dam is mostly suitable. And for this kind of section, as you can see, in case of wide valley separated in two parts, may suggest a combination of two types of dam. See, here the overburden is much more than this part. So in here we can use the combination dam. Okay. So an earth fill embankment may be constructed where the overburden is there. So the earth fill embankment may be constructed in that part, and in that part the considerable and concrete gravity dam. A concrete gravity dam on site can be constructed in this part of the location. Okay, so these are some variation which you can look after before constructing a dam. So that's all for today's lecture. So